Okay, I'm back, and now we're going to look at the black body lab. So make sure that you've opened up that document so that you can be looking at the actual experiment that you did while we're discussing it. So the only measuring device that I want you to know for that experiment was the diffraction grating. Now, there also was the power supply, and you had to know what buttons to press on it in order to get the voltage and the current. And then we also looked at a multimeter, and we used that to measure the resistance of the bulb. But I think that that's a little bit more for a physics class. So I just want you to be able to use a diffraction grating in order to see the spectrum of a glowing bulb. Alright, but what kinds of concepts would I want you to know? Well, could you draw a black body? So could you label the up and down part of a black body curve? Could you label the sideways part? Could you tell me how does the curve change as the temperature of the black body is increased? Okay, and then also, how does the color change of a black body as you increase the temperature? How does the brightness of a black body change as you increase the temperature? Okay, then there was that resistance chart in the lab where you had to find the R divided by R sub 0 on the vertical axis, and then you bounced it off the curve in order to find the temperature of the black body. So go to the lab and look for that chart. I'd like for you to be able to use that chart on the exam. Okay, then there's two formulas that you should be able to use on the lab exam. So the first one is Wien's law, which allows you to tell what the wavelength of light is, where it's at its maximum, if you know the temperature, or if you know the maximum wavelength, you could find the temperature. So I could ask you either of those two kinds of questions. And then the second equation is going to be Stefan's law, and so this one allows you to calculate the brightness of an object if you know its temperature. So you should be familiar with those two formulas on the exam. You should be, with Wien's law, you should be able to really put numbers into that formula. With the other one, well, I could ask you a question like, if you double the temperature, what happens to the brightness? Don't tell me that the brightness doubles, because what do you got to do to the temperature using Stefan's law? You got to raise it to the fourth power. So it would be 2 times 2 times 2 times 2. So the brightness would increase by 16. So I could ask you a question like that. Okay, now let's go to the lab on photometry. So for this particular lab, you should know what a photometer is. Okay, and then you should be able to read a ruler. Okay, then you should be able to make a graph of the apparent brightness of a light bulb versus its distance. Okay, could you describe what that graph is doing? So would it be a straight line, or would it be a curved line? Maybe you ought to look that up in your lab. So when you graph the apparent brightness of a light bulb versus how far away you are from it, you're going to get a particular kind of graph. You should be able to recognize that graph on an exam. Okay, then you got the formula for photometry. So F is the apparent brightness of an object, L is the real brightness, and then it's divided by 4 pi r squared. So that's called the photometry equation. So I could ask you, if you get 3 times further away from a light bulb, how bright does it look? Okay, so you don't tell me that it's going to be 3 times dimmer. Because what do you got to do to the r? Look at the formula. You got to square it. So it's going to be 9 times dimmer. Or you could say 1/9 as bright. So either of those two answers would be correct. All right, let's go to the lab on stellar parallax. So for that lab, let me go down to it here. So for that lab, you need to know, why does a star appear to go back and forth as the year progresses? So what is really happening? Is that star really going back and forth in the night sky as the year progresses? Or is there some other explanation for it? Okay, you should know that by reading the lab. Okay, you should be able to measure the parallax angle. So if I gave you a diagram and asked you where in this diagram is the parallax angle, you should be able to identify it. So that is in the lab. Okay, then there was a formula. So you had the parallax formula, which is the distance to a star, r, is equal to 1 divided by the parallax angle, theta. So if I give you the parallax angle in arc seconds, you could put it into that formula and you could calculate how far away that star is. Or if I tell you how far away the star is, you should be able to calculate what the angle is using that formula. Alright, and then if I give you the conversion factor between light years and parsecs, could you convert back and forth? So if I said that something is 2 light years away, could you tell me how many parsecs away it is by using the conversion factor? So that might be another thing that I would give you about that. Alright, so let's stop this video, and then when we come back, we're going to do spectroscopic parallax.